The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, or good evening, or good morning, wherever you are in the world. This is Kevin Jones speaking from PCI Geomatics, and I just wanted to give you a 1-minute warning to let you know that we'll be starting the webinar just in about 1 minute. So we'll just give everyone a chance to settle into the room, and we'll be back just in 1 minute. So hopefully everyone sees my screen at this point, and you should be able to see the presentation which we'll be using. And we'll be back in 1 minute. Okay, so let's get started with today's webinar. How to Ortho Mosaic 50-year-old historical air photos the easy way. And the subject of our webinar today is historical air photo correction. And we're really grateful to have with us the City of St. John, New Brunswick. And so welcome to the webinar, and let's get started. So just in terms of logistics, the lines are currently muted. You should only be able to hear me at this point. And the questions panel is available to you if you have any questions whatsoever. If there's any problem or anything like that, towards the end of the session, we'll be having an interactive Q&A. So feel free to raise your hand. We are recording this session, and we will make a link available if you want to share it with your colleagues or if you want to rewatch the webinar. So today, our presenters are myself on the left. So my name is Kevin, and I've been with PCI Geomatics for about 7 years now. And essentially, I am the Director of Marketing and Business Development, and I currently manage the pre-sales team and put together a lot of these demonstrations for you to learn about PCI technology. Yves Leger on my right is the GIS manager for the City of St. John. He has been there since the year 2000, so going on 16 years. And he holds a master's degree in geography, specializes in geomatics. He obtained that from the University of Quebec in Montreal. He also is a certified GIS professional. He has worked quite a bit with the project management, and in general has a lot of experience with GIS data, and we're really pleased to have Yves here today with us. He's also served as the chair of the Canadian Geomatics Institute New Brunswick branch, and he's been the vice president as well to the Canadian Institute of Geomatics in 2014 and 2015. So great to have Yves with us, a leader in geomatics in Canada and in the Maritime region, and he's been instrumental in helping us put together today's webinar. So just in terms of a quick poll, we always like to know who is with us and what your interest is. So we're going to launch a quick poll here and just find out if you're currently managing or own or maintain historical images. We like to know whether this is obviously a topic that you're currently struggling with perhaps, and to get a sense of who is here with us. So this information is really useful for us to, once again, understand the audience and to position the message accordingly. So quite a few of you have voted already. It looks like about 65% have voted, and over 70% do indeed have maintained historical air photos. And for those of you who are not sure, you can certainly hit Other And then if you want to clarify, you could just use the questions panel or the chat window to provide the information on that. So thanks very much for all of you who have voted. I'm just going to close that down in a few seconds here, so I'm just going to count down 3, 2, 1. Thanks very much for everyone who voted. And I'll just quickly show the results here so you can see 65%, 33%, and 3%. Great. So let's keep going. So let's talk about our outline. So we have a very ambitious agenda here that we want to get through in the next hopefully 45 minutes. We want to first talk about the value of correcting historical air photos, and we're going to do that through the testimonial, if you will, or the experience of Yves Leger, who is with us from the City of St. John. So he's going to walk us through the current status of their archives, some of the previous things that they've tried to do, the version of the mosaic that we have been able to generate from his imagery, and how that helps, and then also he'll talk a little bit about potential application examples. After Yves presents, we'll move on to a workflow overview. So I'll be walking you through the historical air photo processing. I won't go through a complete project, but I will be walking you through the essential elements of the project. And the key thing here is that we are making available the complete data set, or a subset of the data set. So here we have a special offer. So what we'll be providing you in the coming days is a package that includes historical air photo software, so you'll be able to use the software. You'll have access to a course that we'll be making available on Udemy, and the imagery and all of the supporting information that you need for the processing of the data. So hopefully by the end of this webinar you understand what HAP is capable of, and if you want to pursue it further and get a real sense of how the software works, we're giving you everything that you need to try this out for yourself. So I'm going to pass over to Yves at this point. So Yves, let me just unmute your line. You can unmute it yourself as well. Here we go. So you're unmuted. Can we hear you, Yves?
Yes, can you hear me?
Yeah, perfectly. So why don't you take it away? I'll advance the slides. Just let me know when to advance the next slide.
Okay. Hello, everybody. I'm happy to be here. This is my first time doing a webinar like this, so forgive me if I'm I'm not as professional at this as Kevin. I'll just give you a little run through of what happened here at the City of St. John. Shortly after I started working here in the year 2000, I discovered boxes of historic air photos that were just sitting in the planning department archives. And because of where they were stored, they weren't very accessible to a lot of people. So I knew these did have a lot of value, and so I wanted to make them as accessible to people as possible. So, and especially we're going to focus on the 1967 series here. Those photos were taken because of the amalgamation that took place with the city of Lancaster to the west and the parish of Simons to the east of St. John. So it represents a crucial point in St. John's history. So I knew these would be very useful to people. So what we did at first was we scanned each photo using just an office scanner that was capable of scanning 11 by 17 so that we could make sure we got the surround information on the photos. And we scanned those at 600 dpi and saved them as TIFFs. But because each of the TIFF files were fairly large in size, we also saved each of these as JPEGs and created a simple web page that you see on screen now, where people could go and see where the photo centers were for each of those 67 photos. And if you clicked on one of the photo centers, it would bring up the photo so people could view them. This was pretty good for a while, but in 2015 we launched an open data portal, and all of the scanned air photos are now freely available. And if you want to check out what we have available in our open data portal, you can just go to stjohn.ca/open-data. So while these were useful, we really wished that we could have these as an Ortho Mosaic. And we hired a new GIS technician a couple of years ago, and he decided to try to create a mosaic using Microsoft Image Composite Editor, which is freeware. And while this was an improvement over what we had, it took a lot of effort and processing time, and in the end the quality wasn't great because the images had to be downsampled. So you can see the jagged edges and poor radiometry. So, when Kevin contacted me and asked me if we would be open to him using our 67 series air photos to create an Ortho Mosaic using PCI software, we were very open to the idea. And as you can see, the accuracy is a lot better, the fidelity, the quality. And so far, this new Ortho Mosaic has already proven extremely useful in various ways. For one, it's helped young planners that are starting work here at the city to better understand how land use has changed in certain neighborhoods and see where urban sprawl has occurred. You can see forestry stands, heights. It's also been used by the police department. They've contacted us as part of a cold case for a missing person. They wanted to know what was in the area of interest in around 1967. So it was nice to have the historic air photos to be able to look at and show them what was in that area when the person went missing. The other use that has been the mosaic's been used for is in St. John, when amalgamation happened, private streets that were in the city of Lancaster or the parish of Simons were grandfathered and continued to receive snow plowing and surface maintenance by the city. However, during the past 50 years, some newly developed private streets have creeped in and are now being serviced and maintained when they shouldn't be. So now, because of financial constraints, the city's trying to revert back to only service and maintain the ones that were in fact grandfathered in 1967. This is, as you can imagine, a contentious issue for the past few years, and there's been many disputes as to whether or not a street existed in 1967. So the Ortho Mosaic is a really useful tool to be able to clearly see if a street was there in 1967 or not. So those are the uses that we've been able to use the Ortho Mosaic for so far. I'm sure there's going to be some more uses, but that's it for now. Thank you.
Great. Thanks so much for that, Eve. Hopefully that sets the stage and people understand the usefulness of this imagery. So we are just going to have a quick poll here. So we'd like to know what the biggest pain points are for maybe doing this yourself. We heard from Eve some of the pain points that they had. Let's hear from you. So some of the issues are typically the data source is poor quality. Maybe the pictures have deteriorated. Some of you may think that the scanning of the imagery is too costly, although we heard from Eve there that they actually used just a simple office scanner, which did the job. The other options, maybe the resources that you need to correct all of these images are just too expensive. Access to imagery, maybe they're just not available or difficult to use. And maybe it's poor software tools, just the fact that this is there isn't an operational workflow. So I think you can pick the ones that are most suitable for you, and hopefully we get a sense of the key pain points that you're feeling. So This is, so far we've got about 70%, so I'm just going to leave it open for a few more seconds. I'm going to count down from 3, 2, 1. Thank you. And I'm just going to show you the results. So it looks like quite a few of you don't have the resources required, or think that this is taking too much time. Many of you think that the data quality just isn't there to be able to do this. Surprisingly, not a lot of you think that the scanning is too costly, so that's encouraging. And many of you think that the software tools are maybe not there. So thanks for those answers, very useful for us to know. And I think for the audience as well to benefit from the knowledge of the group in terms of what the challenges are. So I'm going to switch now to the solution, if you will. So PCI Geomatics is, as many of you may know, a Canadian company that has provided geospatial image processing software to the industry for over 35 years. And really what we like to do is to kind of describe our technology in the following way. We provide operational efficiency across our platform. We have both desktop software and high-volume production software. So Geomatica is our desktop software tool. GXL is our high-volume production tool. And all of this technology is scalable and flexible, mainly thanks to the fact that we have automation. And the software that we're going to be using today, which is historical air photo production, was actually automated using our own algorithms, if you will, and chaining them together into a workflow using Python as the glue, or as the piece of code that allows us to string together these multiple individual algorithms. So really this is what PCI Technology is all about, and really it's a development platform, or an application platform. So we have, at the bottom we have our algorithms. We have 550 algorithms that can actually be used in a developer edition. On top of that, we have our development environment, which is the Python API. And we can do things like integrate third-party tools. Maybe there's some functionality somewhere else that we need to use. We can use expert knowledge, and then based on all of that, we can build specific solutions. In this case, we've actually developed HAP ourselves as a solution for correcting historical air photos. So the solution at the top of this pyramid, which is made possible by everything underneath it, is the historical air photo processing software. Now, just quickly looking at HAP, what it's all about. The actual software is a highly automated Ortho Mosaic production system for large historical air photo projects. So it's really different because it's optimized to accurately collect ground control in an automated fashion. You'll see that our software uses automatic ground control point collection techniques for using even newer imagery, which is where the landscape has changed quite a bit. Our software is able to collect ground control points and use that to correct a full data set. The software is specifically designed for medium to large projects, and it can be it can work with very large projects, and we've got clients who've used the software for very large projects. The reason we are doing this webinar and the way that we've packaged this is because the new version of Geomatica currently is Service Pack 2, Geomatica 2016 Service Pack 2, and you'll notice that there's now a HAP icon. So the trial license even ships with the trial license of historical air photo. Previously, it was a separate workflow, but now it's essentially available through the Geomatica toolbar. So when we click on this, we essentially get the historical air photo package. Together with the historical air photo package, we have other tools available to help us in our analysis. Primarily, we'll be using Ortho Engine, which is our main software tool for performing things like automatic GCP collection, extracting elevation models, generating ortho, corrected imagery, and also mosaics. In addition, we can use the Mosaic tool. This is a new tool that's available in Geomatica where multiple users can perform edits to the mosaic simultaneously. The HAP toolbar is fairly straightforward. We have three panels. The first one is Ingest, so this allows you to read in the TIFF files which have been scanned in. and associate the metadata. The nominal georeferencing is essentially a step where we associate the scan TIFF imagery to the metadata. And then the alignment is our main panel for performing the iterative alignment steps for the project. So this is where the automatic collection of ground control points and tie points occurs that allows us to produce a nice looking final result that's highly accurate. In terms of the overall workflow, there's several steps, and I don't want to go too much in detail in all of the different steps. I'd like to instead show you in the software some of these initial steps. Essentially, the first part is to prepare the data. That means making sure that we have reference imagery, that we have our scanned images in good enough resolution. We can see the fiducials, this kind of information. We then perform a data ingest, so we associate the metadata that we create with the TIFF images which have been scanned in. We then can go to the step where we produce a coarse alignment, so we roughly position the images where they belong in terms of the reference mosaic, and from there we can perform multi-pass image alignment, and we're always improving the camera model, the exterior orientation, the alignment of all of the images to each other using tie points and block bundle adjustment, and also the ground control. So really what we're trying to do there is QA or verify that our model is accurate, and to ensure that we have good quality model so that we can then go to the step where we can create elevation models and create ortho images and mosaics. So that's really the final step, but everything that comes before is made possible through automation using the HAP tool together with the focus viewer to do QA, and Ortho Engine as well to look at some potential sources of errors. Just to give you a sense of some of the processing projects that we've done for clients around the world, this gives you an idea of the year of acquisition, the number of photos, the actual processing time using manual methods, and then the processing time using HAP. So in some cases we are quite a bit faster, and this is obviously a great benefit to end users. So this really is helpful for customers around the world. And I want to switch now to a live demonstration, so bear with me if anything goes wrong. I'm going to attempt to essentially replicate what you'll be getting. So if I just quickly go back up to this page, after this webinar is complete, probably in the next day or so, you will be given access to a self-paced course on Udemy. This is a online learning platform that we are starting to use at PCI Geomatics. So we'll have a free course available. You'll be able to download the imagery from the City of St. John. You'll be able to access the trial version of HAP. And we'll have step-by-step videos to teach you how to use the HAP system to achieve the same result. So if I just quickly go back to where I was. So I'm going to essentially do a subset of the full imagery. So we'll be providing you with 18 images, so 3 flight lines roughly to the north of St. John, the downtown St. John portion. I'll do an end-to-end workflow. I'll show you DSM and DTM, and then I'll also show you Ortho Mosaic and color balancing if I have time. But really what I want to do is show you the project. So let me just open up HAP. So here we have Geomatica 2016. This is Service Pack 2, and when I click on Historical Air Photo, I have this tool which opens up, which is the Historical Air Photo software. And when you register for the course, you'll be given a link to this folder. At this point, there really isn't anything besides what you need to get started. These are the images that have been scanned by the City of St. John, so you can see that the images are located here. There's 18 images. They don't have any georeferencing. These are not geotiffs. They're just straight up TIFF files. in the metadata folder, we've created a metadata file for you. So let me just open that up really quickly. It's in the format that's required for HAP to be able to ingest it. So we have the roll number, the photo number, the file number on disk, or sorry, the file name on disk, and then we have some information that we obtained from the City of St. John's. We have the approximate scene center, we have the focal length of the camera, the approximate altitude at which the pictures were taken. We have the size of the prints, so they're 9 by 9 inches, which is very common. And essentially this is the information that we need to start our project. The reference folder is going to contain a few things. So you will have access to a DEM. This is from SRTM USGS. So we downloaded the SRTM DEM and cleaned it up so that you can use it in this project. This is the reference image that you'll be using. So this is the 2004 Mosaic that is being provided from the City of St. John. In addition, you will have access to the centroids of each image. So this is the approximate scene center location, which has already been calculated by the City of St. John. And you also have the center lines of the streets. So let's take a quick look. Oh, and just before I go there, so one interesting thing that I want to mention is oftentimes with these historical air photo projects, we have some notes on particular images. So here's one of the images, the very first image in the project from 1967. And sometimes you need to do a little bit of investigative work to try to put a project together that's going to be successful. So here we have the name of the company, so maybe using an internet search we can find out information about the particular survey that was done. In this case, Eve was nice enough to provide us with most of the metadata that we needed. We can see here the focal length of the camera. This is the some notation in terms of the pictures. And then here we have some nice notes that tell us about the roll number, the picture number, and then all of the breakdown of the different flight lines. We even have the camera model, so it's an RC8338, and some information about the filters that were used, and the focal length and the collection date. So we essentially can guess that most of these images were collected on May 17th, 1967, so roughly 50 years ago. And so what we'll start with is essentially this blank folder. So the first step is to do the ingest. So we'll open up the ingest panel. We'll point to our images folder. So this is where our images are located. So I'm just going to paste that path in there. The metadata is located in here. So I'm just going to right-click and get that path and paste it in. Just going to get rid of the quotation marks there. And then the input folder, so this is where I want to actually ingest my imagery. So let me just create a folder, call it ingest. And I'm going to copy that, paste it in, and I'm going to hit run. So if I back up here and I open up the ingest folder, we can see that essentially it's created a folder. It's collecting some key information relating to the images based on the metadata and the actual images. And it just took a few seconds there to collect that information. So that's essentially step one. At this point, I don't have any georeferencing information yet. If I were to open up these images, you can see them in here. They don't have any georeferencing information yet. What I need to do is I need to actually collect the fiducial marks off of the images in order to position them roughly where they belong. So you can see here that I just have pixel and line coordinates for this particular image. But it has been read into the system, and what the system has generated for me is this Ortho Engine project which I can begin to work with. So let me just close this down. I'm going to open Ortho Engine, and I'll just drag the fid.prj file over, and the project is already set up for us. So if, for example, if I go to data input, you can see that all of the 18 images, they're already set up. That's because I ran through the ingest step. I was able to bring all the images in. If I back up to the project level, by default, the HAP software sets the pixel size to 10 meters. Now I know that the real benefit of this historical imagery is I can get down to much higher resolution. So I'm going to set the resolution of my project down to 40 centimeters. I'm going to leave everything else the same, and that's it. So I'll go down to the GCP tie point collection step, and to the data input step. What I need to do now is to collect the fiducials. So let me open up the fiducial window, and essentially none of these have been collected yet. So you can see that they're all blank. I don't have any information relating to fiducials. Now luckily the system doesn't require us to collect all of them. We can simply collect a template, and then we can associate that template to the remainder of the images. So let me just quickly zoom in here. It should only take me a few seconds. So I'm going to set that one, just roughly position the fiducial in the right location. Then I'm going to go over here to the top right, set that one in there, and I'm going to zoom into the bottom right, set that one in there. So I don't need to be too precise. I just kind of roughly trying to position it here so that the software can try to find the other fiducials in all of the other images automatically. So I'm going to set that one there. So I've collected my 4 points, and I will choose auto fiducial collection at this point. I'm going to use a threshold, so basically I'm trying to kind of broaden the search radius for the other fiducials. And there will be a report that's going to get written here in this folder that's going to report back the progress of the auto fiducial collection. So this step really doesn't take very long, and in a minute here I'll have the fiducials and I'll be able to assess the quality of the fiducial based on the automatic collection here. So it should only take a few more moments. Okay, so I can go ahead and open up that report, and essentially you can see that the fiducials have been collected. So if I have numbers in these columns, basically it's telling me that everything is okay. I also have a report that's telling me that all of them are okay. The only one that hasn't collected 4 fiducials is this particular image. Now I could go and collect a 4th fiducial if I wanted to, but the system can actually work with only 3, so it's fine. I can leave it like this. So that's the ingest step and the fiducial collection. So I'm going to save this project, and the next step in terms of using HAP is to do a nominal georeferencing. So what I need to do is I need to point to that file where I've just collected the fiducials, and I need to choose a reference elevation model. So as I mentioned, we do have a reference elevation model here, so this is available, and the reference, the output folder where I want to place these nominally georeferenced images. So I'm just going to create a folder called nominal, and I'm going to go ahead and hit run. Okay, well, such is the nature of live demonstrations. Sorry for that. I must have entered one parameter wrong. I'm not quite sure where it is. But I'm going to move on. Maybe it's that one. There we go. Oh, saved it. So I was just pointing at the wrong file. So I have my nominal georeferencing, and I'm just going to use this as a QA step. So now I am able to roughly have these images positioned on the map. So if I zoom out, you can see that these images are roughly in the right location. I can load my reference image underneath it. And I'll just zoom out here to get a sense. And really all I'm doing here is I'm performing QA. So for example, I'll just enhance them all together, and it looks like these images are roughly lined up. Of course, this is not a final product, but I can select an image, turn it on and off, and look and see if features are roughly positioned in the right location underneath. It looks like they are. And if I needed to do any rotation of any images or anything like that, this would be the point at which I would do it. We can see that our flight lines are well organized, so we have 4 images or 5 images on the top, and then about 7 images in the middle, and 5 images on the bottom flight line. The overlap is logical, 60% forward overlap and about 40% side lap. So everything looks pretty good. This is essentially the first step, and the next step that we would do is we could start the alignment stage. Now this stage is a little bit longer, and so what I'd like to do instead is to kind of walk you through a project which I did previously. So the alignment step, I'll just bring up the panel. So the course alignment, I would point to my Ingest folder that I just created, point to my reference elevation model, and then the reference mosaic. And here I can play with different parameters. So when you're doing rough or coarse alignment, essentially you're trying to have a search radius which is broad to find control points. You're also looking for a search radius which is broad for tie points. And then we would specify a location for running our course alignment. Now I'm not going to run it because that takes about 20 minutes for these images on my machine. So instead what I'll do is I will load the results of a previous project which I've already done. Once that step is done, what it will do is it will essentially create an Ortho Engine project which I can once again load. So this is the project that I previously was working with. And if I go to the GCP tie point collection window, I can load up my project. You can see here that everything is looking pretty good. I can select all of my images in the project, and I can show the ground control points. So these are the automatically collected ground control points in the data set. I can show the tie points, and I can also perform some analysis on the quality of the model. So I'll just compute the model really quickly here to show you roughly what would happen. We'll be covering all this in great detail in the course, and you'll be able to follow along in more detail. But essentially what we have here is we have, in this project currently, we have 1,567 ground control points. If I show the distribution of them, if I turn off the tie points, you can see that there are no islands, what we would call islands. So I can pull up the table, the summary table, and sort by RMS, and all of the images have GCP. So you can see that the GCP column for all of the images does have GCPs for them. So there are no images without GCPs, which is good, and they're well distributed, and the overall RMS at this point is 6.9 pixels, and if we switch that to ground units, our accuracy right now is within 3 meters. The tie points, if we switch to tie points, is below 1 meter or below 1 pixel as well. So overall we have a very suitable model at this point to go to the next step. Now to get here, once again, we'll be going through the detail in terms of how to do this in the Udemy course, but suffice it to say that there's an iterative process where we perform quality assurance on the model, we eliminate bad points, and then we groom and improve the accuracy of the model. Once we are happy with our model, which in this case our model is acceptable, we can move to different steps in Ortho Engine. If you're familiar with Ortho Engine, you'll know that we have stereo imagery in this case, and we can actually collect epipolar pairs. So that's what we need to be able to generate elevation models. So I've already done this step. We have automatic selection of pairs that overlap. So we can collect the epipolars, and then once we collect the epipolars, we can generate elevation models and merge those elevation models into one common a DSM in this case. So that's roughly what the workflow looks like. Let me show you the results. So I'm just going to open up a few things to give you a sense of what this all looks like when you're done. So let me just open up Focus here. And I'm going to open up a project which has some results already calculated. So the full mosaic. Just takes a second to load here. So we have kind of 3 steps here that I just want to quickly talk about. The first step is the raw images. So this is when essentially the scanned images that we obtained from the city of St. John. So these are just samples. So at this point there's no georeferencing. After the nominal georeferencing and we made sure that everything was in order, we then went to a course alignment step. So if I look at that data set, you can see here that in this case all 183 images are completely logically organized. We unfortunately have a small little gap here in our mosaic. Eve tells me that they were not able to find 3 of the images from the data set. And then the final mosaic is what we see here. So essentially we have the reference imagery on top, and we can turn on the vectors, put those on top of the data set, and I'll just change the width of that line a little bit to make it look a little bit nicer, and zoom into some of these areas. And if I turn off the old layer, or sorry, the 2004 mosaic and switch on the 1967 layer, you can see that the alignment of the roads on the historical mosaic is very, very good. And just to show you also, because we have stereo imagery, I wanted to show you what a DSM would look like. So just before the webinar, I produced this digital surface model using that model that I was working with in Ortho Engine. And so if I zoom out here, this is just a subset area that I was working in. And I'll turn on the DM editing tool, and you can see roughly what that looks like. So pretty interesting to be able to get historical building heights, maybe tree stand heights. There's information contained in this layer which is very useful to have potentially for applications as well. So that's all I wanted to go through in terms of the demonstration, and I apologize if that was a little bit long, but we'll switch back over to the presentation, and we'll quickly ask everyone a poll, final poll, and we'll go to a few additional items. So let me just pull up the poll here. So we're just interested to know how large your historical air photo catalog is. Is it in the hundreds, is it in the thousands, or the tens of thousands? Do you see this maybe potentially being used for helping you deal with that massive data that you have in your archives? And so we're just interested to see how many images you have. It's not uncommon to have many, many images. We work with several mapping agencies around the world, most notably here in Canada. We work with the National Air Photo Library, and their holdings are somewhere in the neighborhood of 6.5 to 7 million air photos. Those are not all scanned. Some of them are in rolls and or films, and some of them are in prints as well. So quite a variety of imagery in the archives. So I'm just going to close that down in a second here. So 3, 2, 1. And I'll share the results for you to see. So it looks like quite a few of you are in the 0 to 500 range, and then on the opposite spectrum, a fair number of you are in 10,000 or more, which is really interesting. And I'm just going to wrap up the presentation part. So I just want to quickly point out a few other examples. As I mentioned, the National Air Photo Library here in Ottawa has 3 to 4 million prints, but they also have rolls of historical air photos. So in total, they have somewhere in the neighborhood of 7 million air photos. And really the problem that they're having is the storage facility is costing a lot of money. So they're looking for a way to reduce the footprint of their storage facility. We also work with ESRI in the United States. They work with quite a few government agencies, most notably the Department of Transport. There's a link here where you can actually do a live swiping of the different data sets, and there's a story map that you can go to as well. So very interesting here. This is in Utah. They're able to use our HAP system to produce the same quality data that you saw with the St. John data set. And that's been very useful for planning, as Yves mentioned, for that particular user base in the state of Utah. We also have a commercial customer that uses our software. If you happen to have been to this website before, historicalaerials.com, the use of historical images is actually very common in law. There's a lot of cases where you need to have the statement of fact in terms of how things were in the past. For example, where was a fence, or was there a dangerous facility that was located here in terms of the land that I'm buying today. And so historicalaerials.com, our company is called Netter Online. They systematically collect imagery from archives, use our HAP system to produce layers that they then host on their website, which you can purchase. So you can literally zoom to anywhere within different parts of the world, mainly US and Canada, and you can pick an area of interest, and then you can purchase that particular image, all perfectly co-registered to current data sets. So that's all there is for our webinar. I hope that you've enjoyed it. We just want to remind you of the special offer that we have available, the free imagery package, the Udemy course, which we'll be making available, and also the data set and the software, where you'll be able to replicate exactly what I've shown you here today using Geomatica software and the data that's being provided through the City of St. John. So we have additional software or additional resources available. As I mentioned, we have other webinars coming up. We have technical documents that you can access. If you simply go to PCIGeomatics.com/HAP, you can register for updates and keep up to date on everything that's happening with this campaign and then with the software. So at this point, I am going to try to field some questions. I have not been paying attention to the questions tab. Maybe Yves, you've seen a few of them come in. I'm going to open up your line so you can help me out. Can you hear me, Yves?
Yes, I can.
Okay. So we have a question here on the accuracy of the photo center coordinates in terms of the ingest. Can you give us a sense of how you did that, Yves? What was the process for generating those scene centers?
It was basically eyeballing it. So basically looking at each photo and just knowing the city, estimating where the center was and putting a point on the map. So
just someone with our GIS open and plotting coordinates in, dropping points and so on?
Yeah,
okay.
It wasn't anything more scientific than that.
Yeah, oftentimes that is the case. I think what I've seen is some of the people that hold these I guess the National Mapping Institutes, they will have topographic maps with the flight lines plotted on top of the topo maps, and they'll have a rough organization of the flight lines, and so you can enter the first and the last image along a flight line and interpolate the scene centers based on that. Certainly you've seen that as well. Let's see. We have a question here about images having been scanned at 512 by 512 JPEGs. 21 micron, it's supposed to take 5 to 10 years. I'm probably going to take that one offline. It seems like a very good question, but maybe a little bit too involved. But thank you very much for that question. We'll follow up. There's a question regarding services, whether this can be done as a service. So PCI Geomatics is mainly a tool maker, but we can certainly connect you to someone who is using our software that would be interested in providing this kind of service to you. So we'll make sure to follow up with you. A question on whether it's possible to combine images from different cameras. So I am not sure if you could correct all of the data into a single project from multiple cameras in one project. However, what you could definitely do is independently correct the images from the different cameras and then bring all of that together into a common Ortho Mosaic in using our tools. We have a great mosaicing tool where you can take different parts of data sets and bring them together into a common mosaic. We have another question regarding the file size limit of a mosaic. So I don't know of any particular limit. I think you're mostly limited by operating system. The way we typically deal with file size limit in terms of mosaics is we offer tiling. So if your data set is just going to be too big on disk, which might become unmanageable, when you get to the mosaic creation step, what you can do is you can specify maybe a 1 by 1 kilometer tile or some tiling scheme like that to produce the final mosaic. Interesting question on pan sharpening. Whether it would be possible to pan sharpen historical images using newly captured ones. I guess that is possible. I am not sure if it makes sense to use features that aren't matching, if you know what I mean. Probably you have some older features coming through to the color images and you get some misregistration or what will look like misregistration, but really what's happening is you have different features present in the two data sets. So you could do it. I'm not sure if the application makes sense and what kind of results you would get. A question on the coordinates for the metadata. So the question is whether we can use lat long only. We're pretty flexible. The example that I showed you is in lat long, but we can work with different projections and UTM and local datums and so on, and that's definitely possible as well. So that's all the questions we had. We're sitting at 53 minutes past the hour. And oh, we have one more question here that just popped in. So how accurate is the orthophoto when using SRTM with a 40 centimeter pixel? Very good point. And the SRTM obviously is mainly just useful for the terrain. So the registration accuracy could definitely be affected. What we can do is we can actually produce our own digital terrain model from the stereo imagery. So I didn't show it as part of the demo, but we can take the, or I did show the, sorry, I did show the DSM which we generated. So I'll just quickly pull up the DSM once again and show you what I mean. So let me pull that up. And if I turn on the editing feature here, I can create a vector layer. And let's say I wanted to remove all of these buildings here because I want to actually make sure there's no building lean on any of the ortho photos. So I could just, I'm just doing a small area here, but I could do this on the entire image. I'll do a terrain filter to flatten out the building, and I'll apply that. And so you can see that essentially what that's done is it's removed the buildings. I'll just apply it again so you can see it. And really what that's going to allow you to do is to produce accurate orthos. We have this great tool here that we can use for looking at the quality of our orthos. We can flicker between the different orthos that are going to be used. What this is doing is it's essentially providing me a look at any movement that's happening. So we can see that there's movement on the road here, which is on the ground. So I probably need to do some more work to eliminate the possibility that the DM is affecting the orthos. So just kind of really quickly to answer that question, that's hopefully that gives you some clarity. Just going to look and see if there's more question. There's a question about whether you can use HAP without the focal length. So that's a very good question. We get that a lot, and that's why I showed in the introduction this extra image here, which gave us an idea of what this project had been, how this project had been captured. Now we were lucky in this case because we were given the approximate flying altitude and the focal length, and you know, we have even here some of the metadata that's provided with the historical air photo. So if that's not the case, you can still work with HAP. The process becomes a little bit of investigative work, if you will. So if you know roughly when the images were taken, you can search on the internet maybe who was doing surveys in that part of the world, and maybe take a few different attempts at trying to correct your imagery using different focal lengths and so on. So you can definitely do that, and the way that you would kind of assess whether your process is accurate or not is you would essentially pull up the project. So I'm just going to pull up the project here and quickly show you. So you can see that when I was looking at the overview of my footprints, everything looked logical. So the scenes are square, the overlap is logical, and so if the focal length wasn't accurate, I would have some distortion on these footprints, the overlap wouldn't be right, and that would be an indication of a problem with the focal length. So I could adjust the focal length, try to re-ingest my images, and approach the problem once again. So that's definitely a problem that we encounter, and that's the typical way, the way that we typically try to address it. And so there's a question about whether HAP is a standalone package. So yes, absolutely, it is a standalone package. And the main difference that we want to highlight in this webinar is you can actually try it as part of the download trial software on our website. So it is a standalone package, but you can go to getgeomatica.com and you can download the software and you can work with it today. So, and also with this great data set that the City of St. John has provided to us, you'll be able to try it out, do an end-to-end workflow. Well, that's all the time we have for questions. We're coming up exactly on the hour, just about 1 minute shy. And so I'd like to, number one, thank Yves very, very much for his time and his efforts in helping us to put this together. Yves, some closing thoughts.
Well, I just want to thank you, Kevin. This Ortho Mosaic is going to help us quite a bit here. We're very pleased to help you out. Also, if anybody that's in the webinar has any questions that they'd like to email me, they can feel free to email me at yves.leger@saintjohn.ca.
Let me see if I've got that right. At Elegy.
Oh, Yves.leger.
.leger at, and then what was it?
saintjohn, saintjohn.ca.
There you have it, folks. Perfect. Thanks, everyone, for joining today, and have a pleasant rest of your day.